In this example, we're going to look at the greatest common factor and least common multiple. So we looked at these ideas in the last media example, but in this example, we're going to look at them out of context and find a more systematic way of finding them when necessary. So in the other video, we made lists of common factors, and then we found the greatest of them to find the greatest common factor. And we made lists of multiples for the numbers we were given, and then we found the smallest multiple they have in common. So if the numbers are very large, this could be difficult and time consuming, so there's a more straightforward way of doing it if we need to. So let's read the directions. Find the prime factorizations using factor trees for the following pairs of numbers and create the corresponding Venn diagram. We're going to learn what that is and how to make one. Then use the diagram to find the GCF and LCM. So let's start with the first example. We have 8 and 12. So remember, the directions said to start by finding the prime factorizations, and this is how you'll begin to find a Venn diagram. So this is a good start. So 8, I'm thinking of any two factors of 8, and I think of 2 times 4. 2 is prime, so I'm going to circle it. 4 is not prime, so I have to keep factoring. And 4 is 2 times 2, and 2 is prime, so our prime factorization of 8 is 2 times 2 times 2, or 3 factors of 2. We might write it this way. Now let's find the prime factorization of 12. Well, 12 is 3 times 4. 3 is prime, so I'm going to circle it. 4 can be factored further. It's 2 times 2. And 2 is prime, so I'm going to circle them. Now the prime factorization in expanded form, we'd write 2 times 2 times 3. Or in exponential form, we could write 2 squared times 3. So those are our prime factorizations. Now we're going to create the corresponding Venn diagram. So let's see what this looks like. So a Venn diagram is a way of representing what two sets have in common and don't have in common. So I drew a green circle. I'm going to use that for 8, and a blue circle that I'm going to use for 12. And notice I drew them so that they overlap. So you could think of this as maybe one circle is the people in your family who have brown hair. Maybe the other circle is the people in your family that have blue eyes. And if there's anyone in your family with brown hair and blue eyes, you'd put them in the center because that's in both of the circles. So that's what this little piece in the middle represents. It represents the intersection, or the things that both of the sets represented by the circles have in common. So let's look at this with the factorizations. So I'm going to label this 12, so remember what it is, and I'm going to label this 8. So I'm going to start by seeing, I'm going to take a highlighter, and let's see what factors the prime factorizations have in common. So notice they each have 1, 2 in common, and actually they each have a total of 2 factors of 2 in common. So even though 2 is one number, it's not 2 different numbers. If there's repeated factors, you want to include them. So I'm going to put this in the intersection, and I'm going to use red. So I'm going to put the 2 factors of 2 in there. So that's representing 2 factors of 2, not 22. Now, so these are the factors that both 8 and 12 share. So now out here, I would put any factors that 8 has that 12 does not have, because this is only in the green circle. So that's 1 factor of 2. Okay, so I'm going to highlight that because I've used it. Okay, so now 8 has 3 factors of 2. So if I look at the green circle, I have 1, 2, 3 factors of 2, and that's the prime factorization of 8. Now I want to fill in any factors that 12 has that 8 doesn't, would go here. Okay, so that's in the circle that contains 12's factors, but not 8's factors. So the only one there is 3. So I'm going to put 3 in this circle. Okay. So now, once you've made this Venn diagram, there's a really direct, straightforward way for finding both the greatest common factor and the least common multiple. So let's start with the greatest common factor. The greatest common factor is going to be the product of the factors that the two numbers share. So it'd be 2 times 2, which is 4. Okay, so it's the product of the numbers in the intersection. And we'll talk more about this in a second. Let's first write them down. And the least common multiple, you can read this from the Venn diagram by multiplying every number you see. So 2 times 2 times 2 times 3. 2 times 2 times 2 times 3. So 1 from 8, 2 in the intersection, 1 factor of 3, that was in 12. And if we multiply this, this is 8 times 3, which is 24. So now let's think about why this is. Well, for the greatest common factor, you could see that the factors they have in common are 2 factors of 2. They don't have any other factors in common. These ones they do not have in common. So the greatest common factor would be the product of what they have in common, or the intersection. Now let's look at the least common multiple real quick, and let's see why this works. Well, 8 is 2 times 2 times 2. You can see that that factorization is right there. So the least common multiple is 8 times 3, which is 24. Now 12 is 2 times 2 times 3, which are these 3 factors, and 2 times 12 is 24. So notice we found a multiple of 8 and a multiple of 12 using the least amount of factors possible. So to be a multiple of 12, you need 2 times 2 times 3. So we definitely need those. And to be a multiple of 8, we need 3 factors of 2. Okay? So we didn't include an extra factor of 2 because that would be overlap. That would, however, be a common multiple. If we put the other factor of 2, it would be 48. And it would be a common multiple, but it's not the least common multiple. Okay, so let's look at the next one. So our final results is greatest common factor 4, least common multiple 24. So let's start by finding the prime factorizations of 24 and 36. So remember, there are many ways to draw the factor tree, but no matter what way you do it, there's one unique prime factorization. I'm going to do, how about 3 times 8? 3 is prime, 8 is not. 8 is 2 times 4. 2 is prime, 4 is not. Remember, circle your primes as you go so you don't leave any of them out. And 24 has its prime factorization is 3 factors of 2 and a factor of 3. So 2 cubed times 3, or 2 times 2 times 2 times 3. Now let's write the prime factorization for 36. 36 is, I'm going to use 3 times 12. 3 is prime, so I'm circling it. 12 is 3 times 4. 4 needs to be factored further. It's 2 times 2. So the prime factorization of 36 is 2 factors of 2 times 2 factors of 3, or 2 times 2 times 3 times 3. So that's the first step, find the prime factorizations. Now we're going to make the Venn diagram. This is what the Venn diagram looks like. Remember, it's the 2 circles, so I'm going to start by making 1 circle, and I'm going to label it 24. And you can use different colors if you want. You don't have to. It helps you connect the different pieces when you're first learning. So if you have them, great, but it's not necessary. And here we have 36. So now we're going to start making the Venn diagram by writing the numbers in the intersection. So I have a highlighter ready, and I'm just going to scan through. I'm going to start with 24, and anytime I see a factor of 24, I'm going to check to see if 36 has it and highlight it. So I'm going to make sure I do that as I go, because remember, they can have repeated factors. So we have a 2 here and a 2 here. They match up. This 2 and this 2, they each have 2 factors of 2. Well, 24 has another factor of 2, but 36 doesn't. And 24, so I'm not going to highlight that one. And 24 has a factor of 3, and so does 36. So 36 actually has 2 factors of 3, but they only have 1 factor in common. So the common factors are, I should have made this bigger, 2, 2, 3, and let me just write what's there on the side. So I put 2 factors of 2 and a factor of 3 they have in common. Now, what factors does 24 have in addition to these that 36 does not? Well, that would be 1 more factor of 2, and 36 has 1 more factor of 3. So our GCF is the product of all the numbers in the intersection. So 2 times 2 times 3. Well, 4 times 3 is 12. So the greatest common factor of 24 and 36 is 12. Now let's find the least common multiple. Well, for the least common multiple, remember, we multiply all of these numbers, and we won't get any unnecessary repetition because we already included the greatest common factor just once. So not all of these, everything in here, which eliminates extra factors we don't need. So 2 times 2 times 2 times 2 factors of 3. So a 2 from 24, 2 factors of 2 from the intersection, 1 factor of 3 from the intersection, and 1 factor of 3 from 36. And if we multiply this out, 2 times 2 times 2, this is 8, and I'm going to do 3 times 3 is 9, 8 times 9 is 72. So I did that in a way that was easiest for me. I multiplied these, and then I multiplied these, the 3's, 8 times 9 is 72. And remember, since multiplication is commutative, you can multiply those in any order. And for me, that was a nice way to do it because I know all the multiplication tables up to 12, maybe even a little bit higher. Okay, so now we have our greatest common factor of 24 and 36 is 12, and our least common multiple of 24 and 36 is 72. So there are 2 more examples that we're going to do in the next video. So this is part 1 of 2, and I'll see you in a moment.